Greetings everyone. Today we are going to solve the additional mathematics paper of May-June 2023, code 403711, paper 1. Here in our first question, we have been asked to find the equation 5ac square minus 14x plus 8 in the form of completing square plus b whole square plus c, where the a, b, and c are defined to be as constants. Now, we are going to use the formula here, the completing square a x plus b by 2a whole square plus c minus b square by 4. From the equation above here, we are going to find the values of a, b, and c as a form of the quadratic equation. 5 square minus 14x plus 8 goes to 0. We know as a middle fraction quadratic equation, the formation is ax square plus bx plus c is equivalent to 0. So here a equals to 5, b equals to minus 14, c equals to 8. Putting these values in the quadratic equation formula, here 5 x plus b equals to minus 14, so it's minus 14 by 2a, 2 times 5 whole square plus c is 8 minus b square, that means minus 14 whole square, minus 14 whole square divided by 4 times 5. So if you solve that here, we're getting here 5 x plus minus 14 by 10. That means minus 7 by, we're getting here minus 7 by 5 whole square plus, yes, 8 minus 14 whole square divided by 4 into 5. So it's minus 9 by 5. Let me write here. The total value of here is minus 9 by 5 if we subtract the value. So it's minus 9 by 5. This is our equation in the form of ax square plus c quadratic equation form. Now, moving on to the second part of this question. Here we will say that write down the coordinates of the stationary point of the curve y equals to 5x square minus 14x plus 8. So this is my equation. We need to find the stationary point of this. So for the stationary point of this, we know that the value of x is x equals to minus 7 by 5 for the stationary point, that is from the completing square formula, as this defines the value of x for the magnitude of minus 9 by 5, so we can say that this is the value of y also. So differentiating the value and finding the stationary points. So as you know, at stationary points, the value of dy by dx is 0. dy by dx equals to 10x minus 40. Putting the value, dy by dx equals to 0. So 10x minus 14 equals to 0. X equals to 7 by 5. So our stationary value is 7 by 5. Now, moving on to the part C. On the axis below, scale the graph y equals to modulus 5x square minus 14x plus 8. So as we know This graph is a parabolic equation graph from the question, as x square graphs are defined as parabolic equation. Here, x square graphs are parabolic equation which are in a format like this. So now if we find the formula, 5x square minus 14 is solving it the coordinates. The coordinates are found like 7 by 5 minus 9 by 5. This is the value 9 by 5 of the y. Putting this x value in the y equation, we are getting the y coordinate of 9 by 5. Now, sketching the graph. Modulus x of graph defines that all the negative points of the graph gets reflected in the positive one of a parabolic equation. Now, y equals to 5x square minus 14x plus 8. We know that the graph of these equations are like is a parabolic graph. Here, there is a curve. The negative side of the curve is getting reflected up here, and this is a scale. Now, assuming the coordinates of this graph, we know that at this point, if we put the value of x0, y0, we are getting the value of the co-equations from solving it in calculator. One is 2, another one is 4 by 5. So this one is 2, this one is 4 by 5, and the value of x here is, we can say, 8, by putting the value of x equals to 0. This is 8. So we have got the sketching of the graph, but assuming y equals to 0 and x equals to 0, indicating the modulus segment. The modulus segment just reflected the part that was going to be underneath. We can still see here the blue line that I have drawn has been reflected above. This is the work of the modulus, reflecting the negative axis into positive axis. Now, in question D, we have been asked to find the range of values of k for which the equation 5x square minus 14x plus 8 equals to k has 4 distinct roots. Now, as for distinct roots, we know that b square minus 4ac is greater than 0. B square minus 4ac is greater than 0. So we can find the value of a here. A is equals to 5, b equals to minus 14, and c equals to 8. So if we check and solve it, we are getting a range of k equals to 0 to 9 by 5. This value 9 by 5 is being assumed and taken from here as stationary point dy by dx is being 0. So this is the range where the value of k lies. Moving to question number 2. The polynomial p is such that p equals to ax cubed plus 7x squared plus bx plus c, where a and b are integers. Given that p double prime half equals to 32, show that a equals to 6. Now, what does the thing p double prime means? P double prime means that it has been differentiated 2 times. Here, p prime indicates first order differentiate. P double prime defines second order differentiation. So now we're going to solve this. First here, p prime of x. 3ax square plus 14x plus b. P double prime of x equals to 6ax plus 14. We are given that the value of x here is half and it gives out the result 32. So we can say that x is equals to half and p double prime of x equals to 32. That means 6a half plus 14 equals to 32. 6a by 2 equals to 32 minus 14, that equals to 18 now. And 6a equals to 36, a equals to 36 divided by 6, a equals to 6. Sure. Now, given that p of x has a factor 3x minus 4, it has been defined that it's a factor and it has a remainder of 7 when divided by x plus 1. Find the values of b and c. Now, writing the equation here, we know that p of x equals to ax cubed plus 7x squared plus 3x plus c. We know the value of a, that is 6. So we can write it here that the value of a is here 6. So it becomes 6a cubed. It becomes 6a cubed plus 7x squared plus bx plus c. We need to find the value of b and c. Now, as we know that 3x minus 4 is a factor of p of x. It defines that if we put the value x equals to 4 by 3, the output result will be 0. So taking the x value, x equals to 4 by 3 from here, solving it, and putting it in the value here, p equals to 4 by 3 equals to 6 times 4 by 3 whole cube plus 7 times 4 by 3 square plus 4 by 3x plus c equals to 0. That means if you multiply 6 into 4 by 3 whole cube, we're getting 128 by 9. 128 by 9 plus 7 into 4 by 3 whole square is equal to 112 by 9. 112 by 9 plus 4 by 3x. Say 4 by 3b. It's supposed to be b here, not x. 4 by 3b plus c equals to 0. Now, if we add these two, 128 by 9 plus 112 by 9, it gives out a result of 80 by 3. 80 by 3 plus 4 by 3b plus c equals to 0. We can write it 4 by 3b plus c equals to minus 80 by 3. Taking the LCM here, 3. 4b plus 3c equals to minus 80 by 3. 4b plus 3c equals to minus 80 by 3 times 3, that equals to minus 80. This is my first equation. Secondly, we have got that if we now we have given that if we divide the equation by x plus 1 here, we are getting a remainder of 7. That means if we put the value f of x equals to minus 1, we are getting a remainder of 7. So we put the value here, p of minus 1 equals to equals to 6 times minus 1 whole cube plus 7 times minus 1 whole square plus minus 1b plus c equals to 7 minus 6 plus 7 minus b plus c equals 7. That's 1 minus b plus this is my equation 2. From here we can derive a third equation, that is c equals to 6 plus b. C equals to 6 plus b, and putting it here in equation 1. So if we put it in equation 1, we can see that 4b plus 3 times 6 plus b equals to minus 80. 4b plus 18 plus 3b equals to negative 80. 7b equals to minus 18 minus 18 minus 18 minus 18, that is minus 98. Minus 98, b equals to minus 98 divided by 7, that equals to minus 14. B equals to minus 14. Putting in the equation of 3, 6 plus minus 14, that equals to negative 8. So the value of B is minus 14 and the value of C is negative 8. That's good. Now, in the C part, the P of x in the form 3x minus 4qx, where qx is a quadratic factor. We need to find the quadratic factor q of x. From the upper values, we have gotten known that p of x is an equation with 6x cubed plus 7x squared minus 14 minus 14x minus 14x minus 8. This is the equation from the above. You can see. Now, we know that 3x minus 4 is a factor, so we're going to do long division here. X minus 8. Now, if we take here total, we are going to use 2x square. So we are getting 6x cubed minus 8x square. Here it's minus, here it's minus. These two gets cancelled out. It's 15x square minus 14x minus 8. Taking plus 5x here, we're getting 15x square minus 20x. And it's minus, here it's minus. These two gets cancelled out. Minus 14. Minus 14 plus 20. It's basically 6x minus 8. Now if we here take I2, so it's 6x minus 8 divided by 0. So we can see that the p of x has a factor of 3x minus 4 and qx quadratic equation of 2x squared plus 5x plus 2. So we can say that q of x equals to 2x squared plus 5x plus 2. This is our answer. Hence, in equation D, we have said that hence write P of S as a product of linear factors with integer coefficients. Okay, so we are here asked to write in the integer coefficients of product in the factors in the form of factors. So here we have known from the previous question C that our factors are 1, 3x minus 4, and the quadratic equation 2x squared plus 5x plus 2. We need to break this thing into factor by doing middle term breaking. So 3x minus 4. If we break this, we are going to do middle term breaking. So 2 to 4. We need to break this into factors that we are going to see. So 2x squared plus 4x plus x plus 2. P of x equals to 3x minus 4. If we take common here, like it's 2x, then x plus 2 plus 1, x plus 2. Okay. So the answer is 3x minus 4, 2x plus 1, x plus 2. Here's our factors from answers with coefficient integers. Now moving on to question number 3. The points A, B have coordinates 2, 5 and coordinates 10, 5, 15. Respectively, the point P lies on perpendicular bisector of the line AB. The y coordinate of P is 9. Here it will say that we have a line here defined as AB, where A has a coordinate of 2, 5 and B has a coordinate of 10, minus 15. The point P lies between the line where it's a perpendicular bisector, and this point is being defined as point P with the coordinate given y equals to minus 9 and an unknown coordinate of x. We have to find the unknown coordinate of x. For that, we're going to need to find the equation of the line with x coordinate P, the perpendicular equation. So from the, we are trying to get the gradient of A, B by the formula y2 minus y1 divided by x2 minus x1, putting the values minus 15, minus 5, 10, minus 2. That means minus 20, we're getting here minus 15, minus 5 divided by 10 minus 2. It's minus 5 by 2. Now, as it's perpendicular, then m1 into m2 equals to negative 1. So we can say that m2 equals to minus 1 divided by minus 5 by 2, giving a value of 2 over 5. Now, forming the equation, y minus y1 equals to x minus m, x minus x1. We're going to need this equation to find the equation of that. Now, we know the perpendicular gradient here, we know the point. Yes. I guess we don't need the coordinate, gradient of the perpendicular here, so we omit that. We can find it by another way, by using the previous part. We're going to make the equation of the line AB. Equation of the line AB. So y minus 5 equals to minus 5 by 2, x minus 2. We are using this coordinate. You can also use the second coordinate if you want, but as it's simple and small, so it's easy to calculate. So here y equals 2y minus 10 equals to minus 5x plus 10. 2y equals to minus 5x plus 20. Y equals to minus 5 by 2x plus 10. Now to find the x coordinate of point P, we're going to put y equals to minus 9. For point P, we know y equals to negative 9. So x plus 10 equals to minus 9. Minus 5 by 2, x equals to minus 19. X equals to minus 19 divided by minus 5 by 2. So x equals to minus 19. is 38 by 5. We can see here. So putting values to this, we are finding the equation. This is the point. We are finding gradient. The gradient is this. Y equals to minus 105. So this is minus 9. Minus 9 minus 9 minus 10 minus 19 minus 19 divided by minus 2.5. I just made some mistake here. The gradient was wrong. I clicked to the gradient wrong. So we cut out. So here x minus 2 and the gradient will be 2 by 5. The gradient will be 2 by 5. Point P lies in the bisector of the line AB. The y coordinate of P is minus 9. Find the x coordinate. We need to find the perpendicular bisector here. So M1 into M2. M1 into M2 equals to negative 1. So M2 equals to 2 by 5. And putting the gradient here 2 by 5. The gradient here is 2 by 5. And let's as this is perpendicular bisector, we can say that this is the point minus 6. So this one, okay, I'm going to erase this. I'm sorry for this. Continue to erase this. This is something for wrong. This is the point P lies. So the thing is, we know the line AB with coordinates given 2, 5 here, 10, minus 15. So the perpendicular bisector lies here, the line, and point P lies somewhere here. No, not here. It's here as y equals to minus 9, negative 9. So this point is known as the midpoint as a perpendicular bisector. So for midpoint, we're gonna find it. So 10 plus 2 divided by 2 for the formula, and 5 minus 15 divided by 5 minus 15 divided by 2. So midpoint equals to 6, minus 5. And the midpoint formula is defined by x1 plus x2 divided by 2, y1 plus y2 divided by 2. Yeah. Now, moving forward, we need to find the gradient of AB, then the perpendicular gradient. So the gradient is minus 15 minus 5 divided by 10 minus 2. That is minus 20 divided by 8. That is minus 5 by 2. As is perpendicular, so the perpendicular gradient equals to G2 equals to 2 by 5. As we know, M1 into M2 is equals to negative 1. So we have found the gradient, we know the coordinates, so let's make it M. So y plus 5 is equals to 2 by 5 x minus 6, y equals to 5y plus 25 equals to 2x minus 12. 5y equals to 2x minus 12 minus 25. So y equals to 2 by 5x, and that leads to minus 7. Now, as we know, the value of x coordinate needs to be found as y equals to negative 9. So putting the value of y here equals to negative 9, minus 9 equals to 2 by 5x minus 37. If we solve, we are going to get that x is equals to minus 4. X is equals to minus. Now, x is equals to negative 4. So, this is our answer. The coordinates of P is minus 4, comma minus 9. The answer is minus 4, comma minus 9. Now, moving on to the second question. The point R is a reflection of point P in the line AB. So we need to find that the coordinates of R. So if we draw the line, if you see, if this is the line AB, if this is the line AB, and draw this, this is the point P with coordinate minus 4, minus 9. It says the point R is the reflection of P in line this. So if we reflect it, the coordinates we'll be getting are 16 minus 9. So the coordinate of R is 16 minus 1. That is the reflection of point P on line AB. Moving towards to question number 4. Now, we have been shown a graph of velocity time graph. The diagram here shows the traveling time of a particle in a straight line with velocity and t, where t equals to 30. The diagram shows the velocity time graph for a particle traveling in a straight line with velocity v meter per second and time t seconds. When t equals to 30, the velocity of the particle is v meter per second. The particle travels 800 meters in 45 seconds. This is the given information. We have been told to find the value of v. So for the value of v, we know, as this is a velocity time graph, we're going to do first area under the graph of this to find the value of v. So for area under the graph, we're going to do is, we know that area under the graph equals to 800, right? This graph has been divided into one trapezium and two trapeziums, or we can say that it's one triangle, one square, and one trapezium. We can divide it into more, like a right angle triangle, a square, a triangle, and another triangle. So first we're going to solve it in the graph. So half plus 10 into 10. This part we are going to solve. So area of that part is, as a triangle, half base into height plus Now the second portion, that's the distance from here to here, is 10, and the height is also 10 as it's a square. So it's 10 times 10, 10 times 10 plus the remaining part. Here, it's a trapezium. So we're going to use the formula, that's half a plus b into height. That's half a plus b into height. So half, this is the half, this is a, this is b, and this is the height. So here is the value is half times 10, height 10 plus v, as we don't know how much the velocity is, into 10 plus the area of this part, half into 15 into v, that equals to 800. The 15 is from the distance of 30 to 45, that is defined as 15, and the height is given as v, as we don't know this value. So half into base into height. So solving this, 100 into 50 plus 100 plus, it's half times 100 plus 10v, 100 plus 10v divided by 2, 100 plus 10v divided by 2 plus 15v by 2 equals to 800. So if we solve this equation, we are getting the velocity v equals to, if we calculate, we are getting v equals to 48. Now, we have found the value of v by doing area under the graph of this equation. In the second part of question B, we have been asked to find the acceleration of the particle p when t equals to 35. So when t equals to 35, what is the acceleration of v? As this is a velocity time graph, we need to find acceleration, that is by the formula a equals to v minus u divided by t. Acceleration equals to t equals to 35. So t equals to 35 is from somewhere here, and the velocity is given by velocity is given by 48. We know the top velocity is 48, so we're assuming this is 45, this is 10, this is 15, the midpoint is here. So this is 48, 48 divided by 2, 24, 24 by 48 divided by 16. Hold on a second. So under acceleration of t when t equals to 35, acceleration equals to minus u divided by t, and 15. 15. So 35 here it's 15, 15 then 48, 48 divided by 15, that is half. So as we know, the velocity initially is 0, final velocity is 0, and the starting is 48. So 48 divided by 15 equals to 16 by 5, negative 16 by 5, because it's decelerating. As from 35, we know the time is 15 seconds here, and the rate of the deceleration from this point to this point is a constant. So from 30 to 45, the value of acceleration equals to minus 16 by 5, which is same for t equals to 35. The starting point t equals to 35, because it's sliding down and it is having a constant acceleration. Now, in this part, in question number 5, we have said that do not use calculator in this question. In this question, all lengths are in centimeters. We have given this information. In question A, we are given that cos 120 equals to minus 1 by 2, sine 120 equals to root 3 by 2, and tan 120 equals to minus root 3. In a triangle ABC, AB equals to 5 root 3 minus 6, BC equals to 5 root 3 plus 6, and angle ABC equals to 120. Find AC, giving your answer in the form A root B, where A and B are integers greater than 1. So we cannot use calculator here, but we need to solve. So first we draw the triangle. This is a triangle A, B, C. Here AB equals to 5 root 3 minus 6, BC equals to 5 root 3 plus 6, and angle ABC, this angle is been defined as 120 degree. We have been told to find the value AC. So for this, we are going to use cosine rule. As we know, for length, A square equals to B square plus C square minus 2BC cos angle A. So we are going to see that AC square equals to B square. So B equals to, let it be 5 root 3 plus 6 whole square plus C equals to 5 root 3 minus 6 whole square minus 2 times 5 root 3 plus 6, 5 root 3 minus 6 into cos 120. For this cos 120, we have been given that the value of cos 120 is minus half. So AC square equals to 5 root 3 plus 6 whole square. We need to solve this. 5 root 3 plus 6 whole square and 5 root 3 minus 6 whole square. We have been informed that we cannot use calculator here. So we have to use the start from equation a plus b whole square 5 root 3 whole square plus 2 times 6 times 5 root 3 plus 6 whole square, same for that one, plus 5 root 3 whole square minus 2 times 6 times 5 root 3 plus 6 whole square minus 2 times 5 root 3. We can say that it is this thing equals to 5 root 3 whole square minus 6 whole square, as it is in the form of a square minus b square. Why we write it a plus b in the form of a square minus b square is a plus b a minus b. Now if we solve this, we're getting a result of 3 root 29. If we solve this, this equals to 3 root 29. 5 here for the calculation of 5 root 3 whole square is 75. The value of 5 root 3 whole square equals to 75, as 5 root 3 whole square equals to 5 square into root 3 whole square, that equals to 3. So 25 into 3 equals to 75. By doing this simple calculation, you can get this value. Now, in the B section, we are given that cos 30 equals to root 3 by 2, sin 30 equals to half, tan 30 equals to 1 divided by root 3.
In a triangle PQR, PQ equals to 3 plus root 2 5, PQR equals to 30 degree. Given that the area of this triangle is given like this, find QR. So basically, if this is a triangle PQR, we know that PQ equals to 3 plus 2 root 5, PQR equals to 30 degree, and the area is given. The area is given. We need to find this part. So the area of a triangle is half A into B into sine theta. For this particular triangle, we are going to write as half into PQ into QR into sine 30 degree. You might ask why PQ and QR not PR, because in forming of area, the angle that has been defined, we take the lengths beside them, not the other one, the opposite one. So here area is given by 2 plus 5 root 5 by 4 equals to half times PQ equals to 3 plus 2 root 5 into QR into sine 30, that is equals to half. So this half and this half equals to 1 by 4. So 2 plus 5 root 2 by 4 equals to 3 plus 2 root 5 divided by 4 times QR. Sending it there, so QR equals to 2 plus 5 root 2 by 4. Here multiplication, so it was divided into 4 by 3 plus 2 root 5. This 4 gets cancelled. Q equals to 2 plus 5 root 2 divided by 3 plus 2 root 5. This is in third form. Now, it has been said that we need to find this in simplified form. So we are going to take conjugate pairs here. The opposite part of this, the denominator's value. So it's 3 minus 2 root 5, 3 minus 2 root 5. 2 plus 5 root 2 times 3 minus 2 root 5 divided by 3 plus 2 root 5, 3 minus 2 equals 2, a square minus b square form. So it's 9 minus 2 root 5 whole square equals to 50. Oh no, so it's 20. So it's 9 minus 20, and upper here is 6 minus 4 root 5 plus 15 root 2 minus 5 root 2 into 2 root 5. 5 root 2 into 2 root 5. It's 10 root 2. It's 10 root 10. Now if we solve this part, this is 2. 9 minus 20 equals to minus 11. And here 5 root 6 minus 4 root 5 plus 15 root 2 minus 10 root 10. No, it's 50. Sorry, that value is 50. 2 root 5 whole square, that value is 50. It's only 50. So 15 root 4, 15 root 5, oh, so that's 15 root 5 here. So if we now solve this, it's getting minus 11 root 5 and minus 44. 11 root 5 minus 44 who had some issues in the plus minus. This was the answer. So we get in here that QR equals to 11 root 5 minus 44 divided by minus 11. This is the value of our question B. Now moving words, we have reached question number 6 till now. We have been given that cot theta plus tan theta equals to sec theta, and we need to prove that it equals to cosec theta. Now we're going to break that in simplest forms. Cot theta is being written by 1 by tan theta or cos theta by sin theta. We know that cot theta equals to 1 by tan theta or cos theta by sin theta. So now solving onwards, cos theta by sin theta plus sin theta by cos theta divided by 1 by sec theta. Divided by sec theta, we can write sec theta equals to 1 by cos theta here. So it's 1 by cos theta. Now, if we're going to solve this, we're going to change the values. So the cos theta is going to move upwards, but before that, we're going to take LCM of the downwards, that is sin theta cos theta. Sin theta cos theta equals to cos square theta plus sin square theta by 1 by cos theta. Now, that's 1 by sin theta cos theta divided by cos theta. So 1 by cos theta. So if we change that, 1 by sin theta into cos theta. This cos theta has been cancelled, so it's 1 by sin theta, and 1 by sin theta is defined by cosec theta. That's the show. That's done. Now, moving onwards to this. We have given that cot 5 by 3 plus tan 5 by 3 divided by sec 5 by 3 whole square equals to 2. We have been given this. And the revolution has been given, but the range of values has been given, and that is from 5 minus 540 to 540. Now, on the previous part, we have seen that you can write cos theta plus tan theta divided by sec theta is equivalent to cosec theta. Forming this, we can write this equation here is cosec 5 by 3 whole square is equals to 2. We can say that cosec 5 by 3 equals to root over 2. Cosec is 1 by sine 5 by 3 equals to root 2. Sine 5 by 3 equals to 1 by root 2. 5 by 3 equals to sine inverse 1, 1 by root 2. Now, we're going to take all students take coffee. All students take coffee. They are all 5 values are positive. Their sine 5 values are positive. Their tan 5 values are positive. Their cos 5 values are positive. Now, for the part we are solving, 5 by 3 equals to sine inverse 1 by root 2. Putting the value in calculator, sine inverse 1 by root 2, we are getting 45. So the degree is 45 degree. Now, Doing basic acute angle theorem, as sine is positive, so we are getting pi by 3 equals to 45, sine positive, so 180 minus 45 degree, getting 5 by 3 equals to 45 degree, 180 minus 45, that's 135, that's 135 degree. Now, this is the value we have taken for positive. Now, as we have done here, 1 by root 2, this is a plus minus sign here. As we know, if we root some values, we are getting plus minus values. So, this is the value of 5 by 3, 45, and 135. We're going to need more of these values. So, 135 into 3, 405, we are solving. 5 by 3 equals to 45 here. So 45 into divided into 3 equals to 135, and 135 into 3 equals to 405. This is for positive. We got this value by multiplying it with 3. Now, for the negative values, sine inverse 1 by minus root 2. When sine is negative, the values are these and these. So 5 by 3 equals to 180 plus 45 and 360 minus 45. So here 5 by 3 equals to 180 plus 45, 225, 360 minus 45, 315. So 225 into 3 equals to 675. We can see that if we multiply these values times 3, the value is out of range. But we have been told to find the values from minus 540 to positive 540. So as it's an inverse graph of sec or sine, we can see that the graphs crosses these points. So the positive points will have same points as the negative points. So therefore, phi equals to minus 135, 405, minus 405, 135, 405, and that's all. Because both sides have the same repetition values and we don't need to calculate this one. Now, moving to question number 7. A team of 8 people is chosen from a group of 50. Find the number of different things that can be chosen. So we are going to do binary expansion theorem. That's number equals to 15C8, the last value that gives us the result. It's 6435. We're doing this from the binary expansion theorem in CX value. We know the terms of 8 people will be 8 in each term, and n equals to number of groups. So if we do this, we're going to get the answer. Find the number of different teams that can be chosen if the group of 15 people contains a family of 4 people who must be kept together. Number of different peoples. So 4 peoples and 4 people. So first one is going to be like, call that. We can do this 11. Now, find the number of different teams that can be chosen if the group of 15 people contains family of 4. So if it's a family of 4, then the number is 11. So for the teams, 11C4, and we're gonna get 11C8. So the total value, if we add these two values, we're getting a value of 495. Here 11C4, using calculator, we're going to get that 11C4. 11C4 equals to 330 plus 11C8, which equals to 165, resulting a value of 495. Now, given that n plus 9 into np10 equals to n square plus 243 into n minus 1 p to the power 9, find the value of n. This is an equation given and both sides are being given. We need to solve this thing. So first we're going to write it in the formation of factorial form, then we're going to solve this. So it can be written n plus 9 np10, that means factorial of 10. So factorial of 10 is been written by n minus 10 factorial here, n minus 10 factorial, as the term is going to be decreased by the time, 10 factorial times n factorial, because we don't know the value of n here. So solving it down, so n square plus here equals, here in the left hand side we're going to write n square plus 243 times n minus 1 factorial divided by n minus 1 minus 9, n minus 1 minus 9 factorial. Now, this value of the factorial has been taken from this, as we know the values here by NCX form. So in this NCX form, we in factorial form we write it by value of n by number of x factorial. This is the formation right, basically. So solving solving it down, n plus. So the other things gets crossed out because it's the same as we don't know the factorial values. So n plus 9 times n equals to n square plus 243. Here n square plus 9n equals to n square plus 243. This one and this one gets cut, so 9n equals to 243, n equals to 243. 3 by 9. So 243 divided by 9 equals to 27. So n here equals to 27. You see this one equals to n minus 10. Here we can write this n minus 10 factorial. So this one, basically this one and this one gets cut off, and here this one has been multiplied and this one also gets cut off. Now for question number 8, a curve has the equation y equals to 3x minus 4 to the power 1 by 3 divided by 2x plus 1. Show that dy by dx equals to this. So you need to differentiate. We're going to differentiate by the formation of u by v quotient rule. That's v du by dx minus u dv by dx divided by v square. So first we're going to select u, that is 3x minus 4 to the power 1 by 3. If we find the differentiate value, that is 1 by 3, 3x minus 4, 1 by 3 minus 1 equals to minus 2 by 3 into 3. This 3 is a differentiate value of 3x minus 4. So this 3 gets cut, so the value is 3x minus 4 to the power minus 2 by 3. Here we're going to find the value of dv by dx. So here v equals to 2x plus 1. It's easy, dv by dx equals to 2. So we know all the constants and the values we need to know, putting in the values. So dy by dx is equivalent to 2x plus 1 whole square. Here v equals to 2x plus 1 times 3x minus 4 minus 2 by 3 minus 3x minus 4 to the power 1 by 3 times 2. Here dy by dx is equals to 2x plus 1 whole square. We can take common here from this 2. So we're going to take common of 3x minus 4. We're going to take common of 3x minus 4 and to the power. So if we take common of 3x minus 4 to the power 1 by 3, so minus 2 by 3 and 1 by 3 equals to minus 2. Okay, so when we take here x, we can write it 2x plus 1, 3x minus 4 minus 2 by 3 minus 2, 3x minus 14 by 1 by. So as you know, we have taken the common 3x minus 4 minus 2x plus 3. So it's 2x plus 1 minus, now there's the same number, the power gets divided. So 1 by 3 divided by minus 2 by 3 equals to minus half. So here we're writing minus 2 times, there's no space, so I'll write it here, 2 times 3x minus 4 to the power minus half. I erase this one. So and dy by dx equals to
2x plus whole square, keeping it down, this 3x minus 4, the downwards 3x 4 to the power 2 by 3. The upper that thing is left, 2x plus 1 minus 2 times 3x minus 4 to the power minus 5. That's not supposed to be this one. So it's supposed to be 1 here. It's supposed to be 1. I just made a mistake here. It's supposed to be 1 here, not minus half. It's supposed to be 1. So if we solve 2x plus 1 whole square, 3x minus 4 2 by 3, 2x plus 1 minus 6x plus 8. So it's minus 8x, 9 by 2x plus 1 whole square, 3x minus 4, or 2 by 3. So should be 9 minus 10, so minus 6x plus 8. So minus 6, 8, minus 6x. Oh, sorry. So it's supposed to be 4x, not 8x. It's 4x. It's minus 4x plus 9. That's the answer. Now, in the B section, it is going to find the coordinates of the stationary point of the car. As it is given at stationary point, we know at stationary point dy by dx equals to 0. So this equation is the differentiated equation. So we know dy by dx is equivalent to minus 4x plus 9 divided by 2x plus 1 whole square, 3x minus 4, 2 by 3. Assuming that dy by dx equals to 0, these things go this here, so we are left with minus 4x plus 9 is equals to 0, x equals to minus 9 by minus 4, x equals to 9 by 4. The x coordinate is 9 by 4, putting the value in the upward equation y, and if we insert the value, we get that the value is 0.255. Putting x value in y equation, x equals to 9 by 4, y equals to 0.255. Now, for question 9, the first three terms of an arithmetic progressions are LQ, LQ4, and LQ7. Ln Q, ln Q4, ln Q7, where Q is a positive constant. The sum of two n terms of this progression is 4845 ln Q. Find the value of n. So we know here the first term is ln Q. Difference equals to ln Q4 minus ln Q equals to ln Q3. And the sum of n terms is of n equals to n additions n by 2, 2 plus n minus 1 times t. Four eight four five ln
plus n minus 1 into ln q3. So 4845 ln q equals to n by 2 to ln q minus n ln q cube minus ln q cube. Moving to these two ones, so n, if we take here, I have to multiply this thing. If we multiply this thing, so n ln q minus n square by 2 ln q cube minus n by 2 ln q cube equals to 4845 ln q. Now, if we transfer this 3 back here, so it's written n ln q minus that's 9690. We can write this equation 3n square plus n plus 9690 equals to 0. If we solve this equation in middle term break, the value of n will be given. So n will be equal to 57. There we go. I've been given the value. Oh, this will be n plus. This will be plus. Less. We are getting it from calculator by solving middle term. No. The first three terms of a different geometric progressions are given by 4 by 3 cos square 3 theta, 6 by 9 cos 4 3 theta, 64 by 27 cos 6 3 theta. We have given the range of 0 to pi by 3. Now, for the first term, we know that a equals to 4 by 3 cos square 3 theta, and the common ratio, as this is a geometric progression, the common ratio is 16 by 9 cos 4 3 theta divided by 4 by 3 cos square 3 theta. So r equals to 16 by 9 divided by 4 by 3, 4 by 3 cos 2 3 theta. This is the value of r we're getting. Now, we need to find the set of values for the sum of infinity. So, the equation of sum of infinity equals to a divided by 1 minus r. So, a equals to 4 by 3 cos square 3 theta, 1 minus 4 by 3 cos square 3 theta. Theta, 3 cos square 3 theta. So, now when theta equals to 0, sum of infinity equals to minus 4. And when theta equals to pi by 3, sum of infinity equals to minus 4. For 0 and both pi by 3, we are getting the value of sum to infinity is minus 4. So the range find the set of values of theta for v, the progression and the sum to infinity. Now, for a, when we differentiate it, the equation is given by 3x square ln 3x. We need to use the product rule. So dy by dx equals to, for u here, du by dx equals to 2 3x plus 1 times 3, and dy by dx equals to this ln 3x plus 1. So ln 3x plus 1 is being written by 3x plus 1. Putting the values here, so u equals to 3x plus 1 whole square times 3 by 3x plus 1 plus ln 3x plus 1 times 6 3x plus 1. This one cut, so 3x plus 1 plus 6 plus 1 ln 3x plus 1. We can common 3x plus 1, so it's 3 plus 6 ln 3x plus Here to find the integration for b. 3x plus 1 is defined as u, and ln 3x plus 1 is defined as dv by dx. The table integration formula is u dv by dx equals to u dot v minus integration of v du by dx. This is a formula that we need to use. So in here, we're going to find first du by dx, that is 3, and v equals to integration of ln 3x plus 1. This was not right. The formula of tabular integration is u dv by dx equals to u dot v minus integration of v du by dx. Here, this is our dv by dx, and this is our u. So u equals to ln 3x plus 1, and du by dx equals to 3 by 3x plus 1. dv by dx equals to 3x plus 1, so v equals to 3x squared by 2 plus x. Putting it in this formation, so u equals to ln 3x plus 1 times 3x squared by 2 plus x minus integration of v 3x squared by 2 plus x times du by dx, that's 3x plus 1. It's 3 by 3x plus 1. It's 3 by 3x plus 1 dx. So the first part is ln 3x plus 1, 3x squared by 2 plus x minus integration of 3x squared 3 plus x 2 plus x times 3 by 3x plus 1. We can take this 3 by 2 out of here and write it before integration. 3 by 2 x squared. So taking the values now, 1 3x plus 1, 3x squared by 2 plus x minus 3 by 2 integration of 3x squared plus x by 3x plus 1 dx. 3x plus 1 minus 3 by 2 x plus 2 3x plus 1. And if we take common here, x So x plus 1 by 3x plus 1. No, it's not needed. So 3x squared plus x by 3x plus 1 can also be written by 3x squared plus 3 by 3x plus 1. We can write it here directly. I need to write it another way. Now using reverse chain rule to solve the last part of the integration for the value. So from 3x plus 1, 3x squared by 2 plus x minus, if we integrate the value, we're getting minus 3x squared by 4 minus x by 2 minus 3x squared by 4, 3x squared by 4 minus x by 2 plus 2 and 1 by 6 here because this as we differentiate it, it gets to power of 6. 1 by 6. That's all.